So the next speaker is an Italian speaker, Francesco Fullone. Ciao Francesco, welcome to the Digital Ethics Forum. Francesco is a founder, and promoter of associations, is active in many fields, and is an advocate of the Green Software Foundation. Maybe the only one Italian advocate of the Green Software Foundation, I guess. Francesco, correct me.
No, I'm the only independent advocate.
Okay, perfect. And today he will talk about the software's LCA, software carbon intensity methodology, and other frameworks to measure life cycle assessments of softwares and the like. This talk explores strategies for digital products teams to address their environmental impact. We will discuss methods and to measure emissions from digital products and introduce techniques to reduce them. We will cover design optimization strategies and best practices for development and delivery, involving the entire team in creating more sustainable digital products. Thank you, Francesco, and please go ahead. Maybe Carmen, you can stop your screen sharing. Thank you very much. Thank you. Okay, we can see your screen.
See my desktop? Okay.
Yeah, thank you.
So each Italian has more or less 1.3 unused smartphones. I mean, I have a couple of old smartphones in my drawer. One of them was an old Windows phone. I think maybe I'm one of the 15 users in Italy. Then suddenly Microsoft dismissed the product. The question is why we tend to keep them and why we need to buy new ones. There is not an easy reply, but obsolescence maybe is one of the best answers we can give. And we have two kinds of obsolescence. Obsolescence of the hardware maybe is not more repairable, maybe is too old to run new software, and obsolescence by the software, so we cannot upgrade more the device and we cannot get security updates, so we need to change the device itself. And also we have other kind of obsolescence. The mobile phone was no longer upgradable, the battery no longer had the charge, there are no more room for application or photos, and maybe we need a better camera because the smartphone is our main camera application. I don't know, but more or less some of these kind of obsolescence are not our choice. Is a choice that a producer pushed to us. Sometimes we can solve this problem with different kind of producers, where they can give us repairability, upgradability, expandability, and support, such as the Fairphone. But this is not the scope of the talk. I needed to introduce these topics to go more inside the digital lifecycle assessment. So, how much those abandoned device impact, and how much the waste, electronic waste, impact on European and global scale? On the European scale, we know that for each European citizen is collected more or less 11 kilograms every year of e-waste, including kids. So there is a quite big number. And if we go to the smartphone, a single iPhone has between 80 to 85 CO2 incorporated emission. And if we have more or less two smartphone in our drawer, we have 160 kilogram of emission closed in our house and unused. But this is tricky. How we can know this number, these 80 kilograms of CO2, and what does it mean incorporated in the device? So let's try to go a little deep in the linear economy. How does we produce goods? And because this will help us to better understand the impact of our digital choices. So we have money, work, raw materials such as metal, some precious like gold, and some rare earths. Rare not because there are not a lot of them, but because they are quite expensive to be extracted and refined and transformed. Then we put money, work, and raw materials inside the production system, and magic happens, and we have a microprocessor, LCD displays, lithium batteries, and etc., etc. At this point, we have a product, and we put them in the distribution. We use them, and maybe the drawer will be the final place. But this is not the real story, because in each of these steps we emit pollution and waste, and we create waste. And every time we move from a step to another, we can incorporate those 80 kilograms of CO2 inside our smartphone. So at the end of the process, at the end of the usage of our smartphone, we have 80 to 85 kilograms of CO2 equivalent emissions. What about the digital? So in the digital, the emission is growing year by year. In 2023, we had 3.9% of the global GHG emission was by the IT, but the projection will move to 5.5% of total emission in 2026. And in 2030, by the usage of the AI, number could be more than 12 to 14%, more or less the same emission of the whole meat market. When we talk about emission and when we talk about digital, we have to keep in mind that digital is not only immaterial, but is also physical. So 43% of the emission of the digital world came from the not physical aspect, from the digital aspect, while 57% of the emission came from the physical aspect. So the production of those goods we saw before. And if we will analyze deeply those numbers, we can see that 40% of the total emission depends on the physical production of the end user devices. that's why I think we have to understand better the life cycle assessment if we want to implement and discuss about digital life cycle assessment. Let's try to dig it a little bit in the life cycle assessment. The life cycle assessment is a process that helps us to analyze the production of a good and the impact on the environment. That is the easy definition. It came in 4 phases: goal and scope, life cycle inventory, impact assessment, interpretation. They are not very linear phases, because I can jump from the first one to the fourth one to the second one to the first again, then to the third, because every time I do a new iteration of discovery, new numbers, new elements pop out, and then I have to see again my hypothesis. But we don't have 6 to 8 hours to discuss about the LCA, so let's try to talk about the first 2, the goal and scope and the life cycle inventory. So the goal and scope is what we want to evaluate: a company, a product, a service, a good, and in which system we want to evaluate it. And the best way to do that, also, what we don't want to evaluate is very, very important. And the best way to do that is to use a functional unit. The functional unit is a summary of all the decisions defined, and that help us to better refine and to better discuss with other people about how all LCA of life cycle assessment works. So let's keep the example of the smartphone, and we want 4,000 hours of use to read email, make calls, and send a message in Italy. This will help us to follow the James talk about emails. Okay, let's do the second step of the LCA, the life cycle inventory. In the life cycle inventory, what I do is to analyze for each steps of the production, what are the raw materials, what are the system boundaries, the transformation, acquisition, manufacturing, the logistic, and then what are the outputs, such as atmospheric emission, waterborne waste, solid waste, etc., etc. In this way, we can split our smartphone in different life cycle inventory, and for each of them calculate the right number, and this number is bounded to greenhouse gases. And this can help us to calculate the 80 kilograms of CO2 for our smartphone. Now we have to move on the next step, the step regarding the use of that smartphone to read email and to use apps. So the digital LCA itself. As I said before, let's continue to the email approach analysis, and an email, a 3-minute to read a mail is about 17 grams of CO2, and we send almost 350 billion every day. And having this information, we can try to split how the email works inside our digital system. And to do that, we can use the carbon standard. It is an emission model for the digital world, and it is the equivalent for the life cycle inventory for the physical world. The technology carbon standard came in three different aspects or streams that are upstreams, operational stream and downstream. In the upstream phase is the one related to the development of my email client for the mobile phone. And it has to include all the, I don't know, the laptop of the developers or the office or the network inside the company. Then we have the operational stream, and this is this can be direct or indirect. The direct one, if I have my own data center, and on this data center, maybe I also have some generator, so scope 2 and scope 1 of the GHG standard. The indirect one are related to the usage of a cloud provider. So how much traffic I do produce, how many servers I need, how many services I need in that cloud provider. And at the end, I have the downstream emission. The downstream emission are the application put inside the smartphone of my final user. And let's focus on this. We know an email service is not only inside the end user, but it needs a complex system. But for the sake of the talk, let's try to focus only on the client installed to the smartphone. So we had the previous functional unit of the LCA, and we will update it a little bit to be more usable for the application. 4,000 hours of use to manage emails, where manage email means send, receive, and read 100 email per day with an average of 100 kilobytes of attachment. So that's it. From here on, we can calculate the impact and the emission of our application. And how we can calculate it? We can use an ISO standard 20031. This is from Green Software Foundation, and it is an open standard ISO, so it's free to be used and to be approached. The name is software carbon intensity, and it has different components. The energy consumed by the software in kilowatt per hour, the carbon emitted by that energy. So we have to know which kind of energy we are using, renewable or not. Then we have the carbon emitted through the hardware embedded in the hardware, and we know that because it's the famous 80 kilograms, and we can calculate it with a normal LCA, a physical LCA. And then we have our functional unit. We already have defined it as the needs for to send 100 emails every day with an average of 100 kilobytes of attachment. So we collected all the single brick of our Lego software carbon intensity, and now we can calculate the impact of the software. The thing is that this is we can complicate a lot more this simple formula, because we can split the energy from the energy needed from the whole device to the energy needed for a certain time in which the device is using our application. And we can know this kind of information by, I don't know, in Android, we have the how many time you have run the email application. So we can split every single information, and we can calculate very, in a very specific way how hard the mission of each software. When we have a software carbon intensity, what we have to do is to embed it in our continuous integration application and see time by time how the new release of our software are impacting the software carbon intensity, and how the new feature can increase or decrease the emission. But this is only the top of the iceberg. Why? Because we can use this information to have a little different approach to software design. Do we need to send a lot of email efficiently, or should we change the way we communicate? Or design software too. This is valid also in a broader aspect of software design. Sometimes we don't need software. Sometimes we can change the way we build software to resolve the same problem with different approaches. And sometimes we are too eager to try new technology without thinking if we are solving the right problem. And that's why when we try to implement a digital LCA, an important thing is also to create a digital sustainability roadmap. Because creating an LCA is only to have a number, but not to have a strategy. If we have a strategy behind those numbers, we can create and apply the right choices. And the digital sustainability roadmap can go from the renewable energy to the data center, to the digital work environment, to the data management, to the software itself. And in the software, we can define core values as in do not over-deliver feature that will be not used by our user or customer, on to design also using sustainable user experience, and that's it. It's more or less as I said before, the LCA is just the very top of the iceberg to evaluate which kind of activities I have to do in my software. Last, when we talk about sustainability in the software or building software, we see only efficiency in technology, use of green energy, or buying offset. Okay, it's quite a little more different because we have to talk also about the social aspect of the software, how this software is changing the behavior of our customer. Do we need to ask to our customer to buy a new phone just to read our new shining, to use our shining email application, or is our software accessible by the European law, or a lot of the W3C accessibility law, and do we enable in our all digital approach the right to repair of the device we need to be use it with or software, do we use and collaborate to open source, or do we use it without any kind of give back to the community? And at the end, we have efficient technology and green energy at all. So thank you. My name is Francesco Fullone. I'm a business sustainability designer. I'm a champion for the Green Software Foundation, and I'm advocate for climate product leader. And I'm work with Nicola in the W3C in the sustainability guidelines. And I teach this kind of stuff in university. Thank you.
Thank you very much, Francesco. And we will have our boss, Team Freak, later on during this the fourth session of the Digital Ethics Forum. So thank you very much again. Pietro, we don't have any question right now.
Just an explanation for everyone. This picture of Francesco is not that he is only an artist. We all understand that. But here he is shoveling water in Faenza out of one of the periodical floodings in Emilia we have now because of climate change.
Yeah. It was something not expected 1 year ago, and now is, I don't know, it's the fourth.
In a few days.